Hello guys, my name is Adralike. I'm here to present to you the project on Apache Kafka that I deployed to EKS using my CI/CD to GitHub Actions and running this project with building the infrastructure as code and running it with Terraform. So this you can follow me as I walk you through this project and by looking at everything I'm doing on my screen. Thank you. So this project was deployed with Apache Kafka on Amazon Elastic Kubernetes using the infrastructure as code principles with Terraform. And in this project, I provided a complete production-ready setup with automated CI/CD pipelines and monitoring capabilities. Um, I will walk you through the tools used in this project, which are one, Terraform, and the version that I use is 1.6. And the purpose of using Terraform is to be able to run infrastructure as code to provision and manage AWS resources. And I included the necessary providers used in this project, which are the AWS provider with the version 5.0. And the reason for using this AWS provider is to manage the AWS resources on this project. And I also implemented the Kubernetes provider too with the version 2.25 for Kubernetes resources management, and the M provider also with the version 2.12 for mchat deployment. Yeah, and also I included the time random providers for utility functions. And you see here also, because we are actually working with EKS cluster, the EKS service. The EKS is a Elastic Kubernetes service on the AWS. It is actually managed by the AWS, so you don't have to self-manage it. So all you just have to do is to create your EKS cluster and also create your node group, which is needed to make the EKS Kubernetes service function well. So, like I said, the EKS is a managed Kubernetes service for running the cluster. And on this AWS service, while I was provisioning these AWS services on the Terraform, yeah, I had to I have to provision the EKS content you can see on my screen here, and I also implemented VPC, which is the virtual private cloud for the network isolation, and I also set up the EC2 for compute resources for EKS node groups. Then I set up the S3 for storage Terraform state files. I also set up DynamoDB for state logging for Terraform, and also the one which is also very important before you can actually start using your AWS CLI, your command line on your terminal. You need to have the access from the AWS. So we have the IAM role for identity and access management for secure authentication. And also I implemented the EBS Elastic Block Storage for persistent storage. Yeah, I had to provision all these on the Terraform. And also I also included the kubectl. Yeah, I had to install the command line tools for Kubernetes cluster management, and I also had to install Streamz, which is the operator. Yeah, it's the Kubernetes operator for Kafka deployment and management. And I also installed the M. M is a package manager for Kubernetes. And on this project, you see that we have the CI/CD tool which we use is the GitHub Actions. One important use of the GitHub Action is to automate workflow and deployment for pipelines. And those are all the necessary tools that are actually used for this project. As you can see on my screen, you see everything arranged well in this project structure. So I will walk you through everything that I did on this project. So now I will just start from the architecture of this project. The architecture of this project starts from the putting up the infrastructure components, which is the number one. I will start from the VPC, virtual private cloud. They have the VPC module, where I was able to create a virtual private cloud with public and private subnets. And you can see on the screen, it's all there. The private and the public subnets were configured and provisioned. Then I configured the NAT gateways for internet access from the private subnet. I had to set up the proper tagging for EKS integration, and also I had to span multiple availability zones for high availability. I know you understand what that means. And also here in the EKS, when it comes to the EKS module, I'm actually done with the VPC module. Now I'm walking you through the EKS module. The EKS module, I had to deploy the EKS cluster with managed node groups, and I had to configure necessary IAM roles and policies. Then I enabled the required EKS add-ons, which is the EBS CSI driver. You can actually see it on the screen here. And also I used the T3.medium instances with auto scaling and this auto scaling I made sure that I used 3 desired auto scaling groups for years between the minimum of 2 to 4 nodes. So but the desired auto scaling instances that I use is just 3. So then I also implemented the OIDC module. The OIDC module is known as the Open ID Connect, and the reason for setting up this Open ID Connect is so as the CI/CD workflow, the GitHub Actions, can have access to the AWS. That's why the OIDC Connect is actually giving permission to the GitHub Actions to be able to have access to the AWS services. So then I set up the GitHub Actions authentication, the GitHub Actions OIDC authentication, and I created the IAM roles and policies for secure deployment. Then I configured the trust between the GitHub and the AWS, because Open ID Connect is so important. You have to create a trust. If you are not using the Open ID Connect, there is no way the GitHub Actions will be able to have access to the AWS. So moving on, we have the Kubernetes components, where you can see on my screen where I had to create a file for the namespace. And what's the usefulness of this namespace? The usefulness of this namespace is that we had to dedicate Kafka namespace for all the Kafka related resources. Yes. So then if you see on this other file too, I created the Kafka cluster. The Kafka cluster I had to deploy using StreamZ operator as a stateful set with 3 replicas. Yes, whenever you are working with Kafka, you definitely know that Kafka is a stateful, and also it works with stateful sets. I had to deploy using StreamZ operator as a stateful set with 3 replicas. You can see it on my screen. And also I used a persistent volume of 10 GI. Yeah, it's here, 10 GI each for the log storage, and I configured with appropriate replication factors for high availability. Then you see that also I had to create the Zookeeper, which it exemplifies with 3 replicas for coordination. And for the storage, I use the AWS EBS with that elastic block storage volumes via the EBS CSI driver. Then I configured the GP2 storage class. Then I also implemented the proper